Hello and good evening. Welcome everybody for today's talk. This talk is being held as part of a hackathon that will happen in January. The hackathon is on open source AI, and we're very grateful that Mahati has accepted the invitation to do this talk today. The purpose of doing this talk and other knowledge sessions, which will start from today onwards and will go on till the 13th of January, is for people who are going to be participating in the hackathon and for general audiences to understand some of the concepts that are associated with AI and how to apply these concepts in some of the projects and ideas that they're building out. Uh, a quick introduction to today's speaker. Mahati Bhagwatullah is an LLM architect. She's currently spearheading. She has a master's degree from IIIT Hyderabad, and she has been doing a lot of deep dive into data science for the last 10 years. Mahati's work focuses specifically on natural language processing, and she has worked on very interesting projects which involve knowledge graphs, variational autoencoders and decoders, active learning, and so on and so forth. She has also led a team of data scientists to create impactful products. More recently, Mahati has been working with large language models, the overview of which she will be presenting to us today. And if any of you find legal documents complex to process, good news for us, Mahati has released an open source LLM application for answering legal questions. It is called Lawyer GPT with short inference time. Lately, she has also been teaching data scientists about LLMs, fine tuning, and RAG models, and has even started building her own LLM agency working with clients from the US and Israel. As I mentioned, this talk is being held as part of the knowledge sessions for the Open Source AI Hackathon. As part of this hackathon, the team present today who have helped in building out this talk and the sessions going forward are curator of the hackathon, Bharat Chetty, um, and Anvesha Sen, who is the project manager for the Fifth Elephant and Anthill Inside at Hasgeek. With this, I'll hand over to Mahati for taking us through the talk. For those of you who have questions, you can post them on comments here in Zoom, or you can post them in comments on YouTube, and Mahati will answer the questions at the end of the talk. The talk will be a short one, and the idea is for more question answers and for more interaction to happen. So, with this, I'll hand over to Mahati.
Thank you, Zainab, for a wonderful introduction. Yeah, so without much delay, I just want to quickly get into the talk. Yeah, I hope everyone could able to see my slides and I'm audible. So,
Yes.
okay, thank you. So yeah, what is the main Sorry, yeah. So, what is the main reason why we are actually here today to learn about the landscape of LLMs? So, if you are actually aware of this field of LLMs, which was very fast evolving and has been from like past 8 9 months, we can actually see that there is new model every day releasing, and there is so many new advancements every day releasing, and this is very difficult to track for each individual the entire updates which are actually going on, and the entire which LLM would actually fall where and what is the main use. Like if I have to build a particular application, now which LLM to choose, so on and so forth, that has been a major concern, for which we have actually tried to curate this particular talk called as landscape of LLMs, wherein throughout the session I would actually say initially just introduce you to some of the LLMs might be, but then throughout the talk we would actually see what are the parameters which are important, and to which kind of applications you would actually use which kind of LLMs, such that at the end of the talk at least you would have a little idea, as in if I have to actually run a particular application, what is the LLM, where should I need to look for, and what are the parameters that I have to actually look out for. With this quick introduction, let's actually start the landscape. Now, first, throughout the talk, one more thing I just want to mention over here is that, because this is open source, much of the LLMs which I actually say, and much of the introduction, everything will be oriented towards the open source LLMs. There are other LLMs as well, which I wouldn't cover in this specific talk. Now, the landscape of LLMs, yes, they have actually, I mean, to point out few, I have actually given some of the foundational LLM models over here. They are actually very big players like, Meta, Google, Microsoft, everyone are actually been giving their own foundational models, which are also open source. Like, for example, OPT is from Meta, Llama is from Meta, like Flan, T5, Palm 2 from Google, five models from Microsoft. So all of them would actually release some of the LLM models, and we will see like in the further slides, as in from all these models, which are the kind of models you would actually pick up for your applications. Now, as we have actually said, what are the parameters that you have to choose for you to pick up a particular LLM? First is obviously open source or a proprietary. Now, no brainer, we are actually looking out for only open source options. The second is the architecture. Now, we have to little understand the architecture of that particular LLM such that it would actually help us to choose for what kind of applications, what kind of LLMs would actually need it. Fine tuning strategies. What are the fine tuning ways that are present, and what are the fine tuning ways that people have actually incorporated such that you can actually pick LLMs accordingly? Number of parameters, number of tokens trained on, context length, base foundational models can be fine tuned, storage issues, so on and so forth. We will actually get into each and every detail in the coming slides. To start with, architecture. Now, as you're much aware of, every LLM, at least till now obviously there are actually new architectures which are coming up right now as we are actually speaking. But then till now, at least all the LLMs that we had were mostly based on the transformer architectures, and mostly based on one major transformer block, which we'd actually say encoder and the decoder architecture, wherein you in a particular a transformer model, you would have an encoder block and you would have a decoder block. Now, what is the main use of an encoder and what is the main use of a decoder? Now, when it comes to an encoder, it will actually convert the input is given to the encoder. It would actually encapsulate and summarize that input into a set of embeddings. Now, in this scenario, let's say in this example, I am actually doing a mission translation task wherein I give input as how are you, and I would actually get the output as aap kaise ho. Now, in this scenario, what is the main functionality of the encoder is that it is taking that input language or the source language, understanding the language, and encapsulating or summarizing the entire details into a set of embeddings. That is the main functionality of the encoder, is to encapsulate or summarize the source language. When it comes to decoder, what it is actually doing is it is taking up the summarized data from the encoder and then generating data in the target language. So the main aim of the decoder is to generate the data in the target language. Now, if you actually summarize this, the main functionality of the encoder is to summarize, and the main functionality of the decoder is to generate. Now, accordingly as well, you would use this architecture for your applications. Like now, when you are actually using, when you are actually having applications which are oriented like, text summarizations, or you want a document embeddings, or you want, based out of this document embeddings, you want to classify your text to a certain value, then encoder based architectures would actually work well when compared to the decoder based architectures. And this, there are actually certain blogs as well, though Roberta and Bert were actually very previous very back architectures, like back in 2017-18 type of architectures, is still actually working very good with the text summarization when compared to very recent architectures like Llama. So they are actually a set of blogs which actually define this as well. So whenever you actually have an encoder, like whenever you have something like some kind of an application wherein you have to summarize or you want to encapsulate everything into some a lesser amount of part, then go with the encoder based architectures. Now, on the other hand, where is the decoder architectures working? When you have to generate the text, let that be code generation, let that be text generation, let that be molecule generation, any kind of a generation task that you want to do, or a mission translation wherein you want to convert. I mean, mission translation is also a kind of generation. You're generating the next token. So in all these scenarios where you are actually generating the data or generating the next set of next output word, in those scenarios go with decoder architectures. And very frankly, for us as of now, we are actually having much of the much of our applications, sorry, much of our LLMs which are recently been published and then recently been used are much are based on the decoder based architectures only. There are only few which are from the encoder architecture, which are relatively old as well. But then I mean, they are fine tuning these decoder based architectures also for what I should say, for text summarization, for text classification and all. The fine tuning of decoder on the text summarization has also been happening. But based on the studies, what we have actually seen is, though you actually have a same amount of data, the amount of time for the encoder to converge is relatively faster, and the amount that you spend, for the training and all, the amount that you spend for the training is also relatively less on the encoder based architecture when compared to the decoder based architecture. That being one of the first and foremost parameter that you would actually consider while you choose this LLMs. Then fine tuning strategies, or what is the fine tuning methodologies which were actually happen on the transformers. So if you actually know that this particular GPT-2 or GPT-3 has been released long back in around 2017-18, where they used to generate the text, they used to actually write the emails, but then they never used to give an appropriate output. So none of these models used to give an appropriate output. Now that is when people have started looking out for giving an output like a human like output, that the model has to reply like a human. That is where they have actually started the concept called as fine tuning, where this fine tuning has actually changed, or like this fine tuning has actually led to something called as a chat gpt. Though we actually had some similar models back in 2017-18, but then this fine tuning technologies has actually led to this chat gpt. So that is why fine tuning is also being one of the major important step even today. If you actually see the foundation models, so there are two kinds of models: the foundation models and the fine-tuned models. As we have just seen, GPT is back then GPT is a foundational model. On top of it, fine-tuned is a chat GPT that we are having. So even today, the llamas, the falcon models, or the mistral models, which are the foundational models, are relatively performing are relatively not performing better than their fine-tuned versions. Like Zephyr would actually perform better than the Mistral, because it is a fine-tuned version on top of Mistral. Or Llama chat models would actually perform better than the Llama foundational model. So this being the importance of the fine-tuning as such, that it will always perform better than its foundational model. Now, what are the fine-tuning that is actually usually done to these models? First thing that people actually do is that the process is, there are three steps of fine tuning. The first step is wherein you actually have a set of prompts with you. you actually have a set of prompts with you. So prompts is nothing but your questions with you. You have a set of prompts with you, and you would give the set of prompts to a human labeler to write it down. Like, I just answered these questions. Now once I actually have this prompts and the and the answers for the prompts, these two things, now I'll give this to my model to fine tune. Like, if you actually have this question, you answer like this way. So inbuilt, what the model was actually learned is not actually the answer to the question, though it knows the answer to the question, like, but then how to answer to the question is something that the model would actually learn. Now this technique is actually called as supervised fine tune technique, wherein you would actually have a set of input output pairs, and then you would actually train the model. Now from the supervised, so what they have actually done is they have trained a multiple supervised fine tune models. Now, considering this multiple supervised SFTs, what they've actually done is, in the step two, they give another prompt and then ask each and every model to predict. So in this scenario, like, it is asking A, B, C, D. A, B, C, D are the SFTs which are trained after step one. So it is actually, they are actually asking each of the model to predict the outputs. Now, once they have the output, now what they are asking the human labeler to do is to rank one label on top of the other, such that uh, now they can actually train a reward model. So the reward model is nothing but, it would understand that this output is better than this output. This is the output from the step two, a reward model. Now in step three, what they're actually doing is they're now creating a reinforcement learning algorithm, wherein they are creating a policy, like, RL policy. Now given a prompt, they are asking the policy to predict the answer, and the reward model, which is trained on the step two, to reward the policy. So it would actually reward, saying that if the answer is good or the answer is right, wrong or right, or on a rate of 1 to 5, what is the reward that it actually gives, and accordingly the policy will change its change its output. So this will be actually done in iteration. This is a step three, where actually there is an RLHF, reinforcement learning through human feedback, is actually happening. Now, given this as as a baseline, now initially, when as I've mentioned, in the chat GPT or GPT kind of models, the process has actually been done in a similar way, that step one, step two, and step three. But recently, post that, or in the open source community, what people are actually doing is, rather than they getting into this concept of RLHF, rather than they creating a reinforcement learning algorithms, what they're more concentrating on is the SFT algorithms, the supervised fine tuning algorithms. But the data which has been generated is not again the human generated data. Rather, they are actually picking up a highly curated, highly human curated data sets. So the reason behind you understanding the fine tuning is that whenever you actually choose an LLM, make sure that the data set it is being fine tuned on is fasting, is of high quality, and if in case possible, human curated data set. Or even if you are actually doing a fine tuning task, it is always important that a high quality data, or a human curated data sets, if available for that particular problem statement, if chosen, you would actually get relatively very high accuracies when compared to how much of a good model you actually pick up. If your if your data fine tuning data is actually of good quality, then the accuracies will shoot up very high. So that is being the difference between SFTs and RLHF. So it is always better to pick up the RLHF based architectures, but they're very few to name. And also in the open source community, they're not much of the RLHF. Rather, they are actually SFT based like, fine-tuned versions. Now, the number of parameters. So, what is the basic assumption when it comes to the number of parameters is the higher the number of parameters, the better the model is. For example, like Llama 2 7B versus Llama 2 70B. Obviously, Llama 2 70B would actually perform better than your Llama 2 7B, and so on. Like whenever you actually compare the higher number of parameters, the number of parameters here, I mean like the number of parameters that the network has for it to learn 70b 7b 13b types. So the higher the number of parameters, the better the model is. That is the basic assumption. But then to our surprise, I'm sorry, but then to our surprise, there are actually latest techniques which are irrespective of the number of parameters of the model, but still the models are actually performing better than 10 times bigger the models. Like for example, Zephyr 7b was actually beating Llama 13b parameter model, and it was near to performance of Llama 70b, because of the fact that, again, as I mentioned, there are few techniques that they've actually used while fine tuning, but then the quality of the data was also very good. And very recent, Mixtral 8 cross 7b was actually beating GPT 3.5. The chat GPT in itself is actually very near to or almost beating GPT 3.5. Though the number of parameters of the Mixtral 7, Mixtral 7b was very less compared to the GPT 3.5 or chat GPT, which is 175 billion parameter model. So again, coming back over here, there are certain techniques, especially you can actually refer from Mixtral or Zephyr. These two being very exceptional models with respect to the parameters. You can actually refer to their techniques of how they have actually fine-tuned, and you can adopt some of them in case needed in your applications as well. But obviously, parameters, number of parameters playing the major role. Choose your parameter, choose your model wisely, that even a lesser parameter model would actually serve you better results if the application would actually support, based on the applications, obviously, everything. Now, number of tokens trained on. Now, why has this been important? As I've just mentioned, the quality of the data is very important, as well as the number of tokens it is trained on. Now, for example, I would give an example of Chinchilla. Chinchilla was one of the model, which is 70 billion parameter model. But then it was actually outperforming again, GPT 3.5, which is 175 billion parameter. The reason behind a 70 billion model is performing better than 175 billion model is that because of its number of tokens it is trained on. It is more like a person with less intelligence, if it's given a more knowledge to it, they might actually have a better understanding of the subject than a person who is highly intelligent and reading only less books. So, or like reading only less content. So the similar concept is actually being used in the number of tokens trained as well. That if even if a lesser parameter model, if given a large number of tokens to consume, would actually perform better. Again, coming back to your use case, in case you have the option of consumption of a higher amount of data, just go for it, because that will also increase your accuracies compared to lesser amount of data, obviously. But a major caution over here is that the number of tokens increase doesn't mean you actually give a junk to the model, because the more the junk, obviously junk in junk out, the more the junk, the model wouldn't actually perform better. The quality has to be maintained throughout. Again, one of another example where I actually give the quality is that Phi model from the Microsoft, right? 1.5. have actually it consumed only textbook data. So it has actually trained on only textbooks, and that was actually performing very good than the other set of models. So I'm sorry, I actually forgot the comparison with the other set of models. But when I've actually read, I was amazed to see that. So 1.5, the paper is textbook is all you need. That is a paper. So it has actually consumed the textbook data. So the quality of the data from the textbooks is higher than the any of the conversational data that you would actually find. So when it consumed the textbook related data, the amount of the accuracies it could actually able to perform is relatively very high. So maintaining the quality is at most important. And obviously, uh, instead of you choosing a higher parameter model and lesser data, if possible, choose a lower parameter with data with a higher, lower parameter model with a higher data would actually work for you. That is on the number of tokens that you choose. Now, context length. What is the what is the context length? It is nothing but, how much amount of data would actually would a LLM see before it infers. So if I'm actually giving only 512 tokens as my context length, it would actually see 512 length of data, and then it would give me an output. If I'm actually saying 128,000 as my context length, then it would see 128,000, and then it would actually give me that output. Now, when you are actually going for a context length, again, this is a tricky parameter. This is quite what I should say, quite oriented towards the application that you're choosing. Now, if your application is just to classify or just to extract data from your short sentences. Now, if my input sentences are very short, like a two sentence or a three sentences, then I need not actually go for a 128,000 or a 32,000 token LLMs as well, for that matter. I can actually choose a lesser context window tokens, and still I can actually survive, and I can actually do my application very well. But then if your application is such that I am actually feeding, let's say, an entire document, and then I want a summary of that particular document. If that application is something of that sort, then yes, the context length matters a lot. Then you should actually go with a 128,000 or what, sorry, or whatever be the length according to your document length again. So when it comes to the context length, don't blindly go and pick up the LLM with a very high context length. Rather, you choose wisely according to your application. If your application needs a lesser context window, go with a lesser context window. If it needs a bigger context window, go with a bigger context window. So the same thing, if I'm having a larger documents as in my input, then you would actually go with a higher context length. The vice versa, if I'm having a smaller input size, smaller context length, LLMs would also work. Now, apart from this, obviously, the next big thing is the base foundational model. Now, the base foundational model here, I mean, see, as I just mentioned, not every model is actually a foundational model. Like Zephyr is not a foundational model; it is a fine-tuned version on top of the Mistral. Or even Llama Chat is not a foundational model. It is a fine-tuned version on Llama. There are many actually fine-tuned models on Llama and Mistral, obviously. But then there are a set of what I can say fine-tuned versions, and they are a set of the base foundational models. Now, when you're actually considering these base foundational models, just check it out as in which are being ranked higher on top of the other. Like if Mistral is being ranked on top of the Llama, or Falcon is being ranked on top of the Llama, based on that you can actually choose your what I should say, your foundational model and the fine-tuned model as well. So when you're picking up what I meant over here is when you're picking a model, don't just go with that particular model's accuracy. Also go with the foundational model's accuracy, as in how are they performing. Because at many times, I should say this, that a little fine tuning. Now, if your base foundational model is actually good, then any kind of a fine tuning on top of it would work better than the other kind of a model. So that is the reason why you also consider your base foundational model when you are picking your LLM. Obviously, yes, storage and GPU requirements, how much GPU you are looking out for, how much storage, you can actually afford to. Based on that, you would actually get into which would actually see. And commercial license, I'm not much sure at this scenario, you would actually look for a commercial license. You can actually go for any kind of a license, I feel. Just look out for the license as well. Security, security being one of the major concern in the proprietary based so proprietary based LLMs. In the open source scenario, all of the models in your server, so not much of the security concerns uh, would actually be the problem. And also this cost anchor for your entire research, that also something that you calculate before you choose a particular LLM, uh, which would actually help you in choosing, these are the parameters which will actually help you in choosing a better LLM altogether. Now, variations is nothing but they are actually certain set of variations like alpha, beta, for each model, there'll be a set of variations which are available, which will be actually published in the Hugging Face library pages. Just go through one of them and then you can actually check it out. For some of the for some of the models, there is a code version to it. If you want to generate a code, like Python code or Java code, there's a code version to it. There is a molecule generation version to it. There is a chat version to it. There is a parameter versions. So there will be many variations for each and every LLM. That is also that you can actually consider once, like you know, for you to look into. And so there's a set of resources that I can actually guide. One is openmlguide.org, wherein you would actually have something like an open source models. What are the base models which are present? What are the tuned models that are actually being present? I mean, though it is not an exhaustive list, I should say, these are not at all the exhaustive list, but this is some of the sources I can say. Obviously, you might be aware of Open LLM leaderboard, um, wherein you would actually have many, what I should say, many models out there which have been ranked as well according to their performance in different data sets. So these are also some of the what I can say, some of the open source models that you can choose. But in the context of hackathon, that is fine. But in general, what I usually suggest to people is that when you're choosing a model for productionizing, or in another setup other than hackathons, you can go ahead and choose either one. But in a productionizing setup, what it is always preferred is to not to go with the leaderboard and then choose the model which is of higher importance. Rather, you choose a model, you choose a model near to the performance, which is having a good support. Because when it comes to an industry standards, support for the models that you are actually picking up is also quite important. So whenever you choose a particular model, go with the models which are having support is nothing but Zephyr has a good support, though it is a fine-tuned version. Or Mixtral has a good support. So models which are actually having good support, choose them rather than rather than only relying on the open LLM leaderboard and going with an individual related, what I should say, LLM. So that is the usual suggestion that I would actually give for an industry level, like if if you want to take this to industry level, that is the usual suggestion. But at a hackathon level, you can actually go with the leaderboard. And yes, there is another like another resource that can actually help you, might be that this is this is where you can compare a set of what I should say, a set of LLMs. Like, I'm actually loading 4 LLMs, and then I can query them, and then I see how is each LLM performing. So you can keep experimenting this set of 4 LLMs, 4 LLMs at a time, for you to understand, like, which is actually performing better. At least in the problem statement that you have actually picked up, you can actually see which is actually performing better than the other. Also, this is another landscape LLM which I have created for myself, um, uh, which is having the details of it, such that I can filter it out and check it out whenever I want a particular model to choose. uh, so yeah, uh, in a way I should say, it's not yet complete, but then, if you're interested in getting that Excel in other span of 5 to 10 days, I can actually mail you. Just drop in your mail ID or WhatsApp me in this number, and then I can actually help you with giving that form of an Excel. And yeah, thank you. That's what I actually have for the LLM. I mean, selecting the LLM in the list of landscape. Now, any questions? I'm more than happy to take.
Thanks, Mahati. That was fairly extempore. Raghavendra had a question which I think Bharat has responded, but you could as well. Won't complete systems have both encoder and decoder?
No, no. So, Raghavendra, no. Not all the models are actually having encoder and decoder. They are pretty much, I can say, FLAN T5 is the, or in the T5 series of from the Google. So those are the only models which are actually having an encoder decoder based architectures. But then the remaining all of them, like I should say, like whatever GPTs that you're seeing, Llama models that you're seeing, Falcon models that you're seeing. So all of them are actually decoder-based architectures. They are a little older architectures, like BERT, Robota, or everything which is built on top of the BERT kind of a models. I kind of forgot one more model. So I mean, these set of models are the encoder based architecture. So you can actually split them. There are actually encoder based architectures, there are actually decoder based architectures. So only a T5 series of from the Google is actually an encoder decoder based architecture.
Okay. Thanks for this, Mahati. And Raghavendra, you are on the call. So if you want to unmute and ask further questions, you're welcome to do the same. In the meanwhile, we'll take Bharat's queries. So Bharat had two questions. He said, in the textbook paper, did they use any static textbook data or was it synthetic generated textbook data?
No, no, Bharat. It is actually a static textbook data. It is the original textbooks that they have actually used to train the model. And so is the quality of the model was very good. So it is not the synthetic data which has been generated. So yeah, I guess Raghavendra, you want to?
Yeah, I'm just checking the stream to see if there are any questions. But Raghavendra, Piyush, if you have any questions, you can unmute and ask.
Yeah, I don't have any other questions. Can you guys hear me?
Yes, yes.
Yeah, so but one thing that I did want to know is, like, when you're training a model on a specific data, for example, the textbook data or like conversational data. I mean, first of all, like, I need to let you know that I'm really completely new to this, even though I'm in the IT field. But when I try to understand like how these things are trained, it's so when you have a textbook or something, it's just a bunch of symbols. And how do you take that and then convert it to a point where there is contextual understanding from the model, like, because everything is just information. And how do you train the model to think about information in a certain format, in a certain way?
Okay. That requires a lot of things that I have to say, in fact, to get to that particular point. So I'm just thinking, how can I make it a little shorter? So if I have to actually make it a little quite short, I should say this way, that obviously, as you are aware, that this text that has been present from the textbooks have been converted, like each word is converted into an embeddings, right? That's the first thing which happens. And there is an entire architecture that we are actually talking about, like this in this LLMs, we actually have a set of architecture, wherein there are decoder layers present and so on and so forth. Now, this embeddings, along with the what I should say, weights of the entire architecture, would learn from the concept called predicting the next word. So what will actually happen here is I would give each word as an input and then try to predict my next word. Now see if the predicted next word is correct or not. If it is not correct, I'll send the loss back and then train the model. Again, I'll give the next model. I'll see the loss. I'll check it out. So this way, the entire as such the transformer architecture has actually been built. But this is a very high level answer I can actually say, because how the training or the how the learning happens within the transformers requires a requires a lot of breakpoints. I have to break it down to a large too much of in-depth I should actually need to go through, but then like as in a whole, this is what it actually happens, just like in any other neural network, where you actually give an output and then learn it through the back propagation. This also learns in a similar way. Did I answer at least to a certain extent your question, or you have anything further?
Yeah, I guess we have to dig in a lot deeper to understand the mechanics of this. In a way that lets us compare how human brain works and then how these machines work. Because even though when you're chatting with ChatGPT, it feels like you're talking to somebody who understands. But obviously when you look at the mechanisms, it's not easy to say that that's the same thing that goes on in our minds, right? Because we have an understanding, we have a subjective understanding, and
Yes.
it's really hard to say whether it does it or not.
Yes, absolutely, absolutely. So as I mentioned, this is at a very we have to dig down to a at a multiple levels for this to answer, to clearly understand why is that actually happening. In a span of 5 seconds or 10 seconds, I cannot decode the entire thing.
Okay, but thank you for trying. Yeah.
Thank you.
Okay, just checking if there are any more questions. Give me a minute. And meanwhile, Raghavendra, there is a group on WhatsApp that you can join where Mahati is also present, which is on LLM Landscape. So you're welcome to join there and continue this conversation.
Can you please share the link in the chat, please?
Yeah, it's done. Oops, okay, sorry. I think I sent a direct message to Bharat. Let me try to send a message on chat over here.
While you're doing it, Zainab, I don't have any question. This is Piyush. Sorry, you called my name in between.
Yeah,
I don't
if you
have
had
any.
any questions.
No, I
Okay.
don't have any question. This is super helpful, and maybe I'll ask for that Excel sheet that actually has different parameters. So I think the WhatsApp number is already shared, right? So I'll maybe request that that Excel sheet to be shared across, so that we can actually understand, the different parameters, the different comparison, right? That will give us more insights.
Sure.
Thanks.
Okay. All right, sounds good. So there are no further questions yet, but Mahati, if there are questions, we will share them with you. Meanwhile, for those of you who are watching the stream, you can also post your questions later on the comments link that I have shared. I am sharing the link again on YouTube. So if there are any further questions, the YouTube audiences can post their questions over here. And thank you once again, Mahati, for doing this session at such short notice. And I think this really helps in kickstarting the hackathon and all the conceptual sessions that we're looking at. Once again, thanks to Bharat Chetty, curator of the hackathon, for putting this together. And we will publish an update of the upcoming sessions. But in the meantime, the quick announcements are that our next two sessions will be on the 5th of January. And these will be two very exciting sessions where two resource persons from Microsoft will be doing these two talks in person. And following that, on the 10th of January, we will have Biju Nair, who will speak about the licensing challenges and frameworks around LLMs. This is mainly for people who are building with open source and who need to understand what aspects of their work can be licensed, what aspects of their work can be free and open. So this might be a very interesting session for those of you who are looking forward to understanding some of these questions. That having said, do join the WhatsApp group and also follow the project. And if you are interested in making a submission for the hackathon, you can always ping Bharat and to anybody in the team, including Anvesha, and we will get back to you. Thank you very much once again, Mahati, and look forward to seeing everybody at the next session.
Thank you, Zainab.